Okay, everybody, it's T here in Fairmont, West Virginia, and we are going to go ahead and get started. Welcome to day 2 of the workshop. We've still got people logging in online, so I think we'll have an increased attendance. You can hear me? We'll have increased attendance probably as people get warmed up here this morning. Our first presentation is with Guy Kubic and Mark Lee. They're remote, so you'll be hearing them over the phone. And if you hear in the room, if this goes out, just wave at me. I might not pay much attention to this. Note in the room. They are flushing the water lines here in Fairmont. There will be no potable water. We have made coffee with clean, fresh water, but there's no potable water at the water fountains. So you might buy some water out of the vending machine if you need anything. And as usual, if you have questions, please send them through the Adobe Connect session if you're online, or if you're in the room, go ahead and raise your hand. After the presenters are done, they will go to the breakout session just like yesterday. These two are remote, or they'll be connecting online, so you can go to the breakout room just down the hall and to the right if you have questions for them. Or you can the breakout room at your laptops here, because I know they're all in front of just about everybody. And there too, but you won't be able to. So we're gonna go with Mark Lee and Guy Kubic. You guys ready? All right, go right ahead.
Okay, thank you, Peter. Okay, I got my ready too. Okay, so Mark Lee here in Fairmont. Guy Kubic is Huntsville, Alabama. And we're both in IV and on the SLS system. And what we're over is how we're going to use one of the tools to enterprise our and doing some timing on flight software. So if we go to the next page. This is the agenda. We'll do a brief overview of the SLS flight software, description of enterprise architect, a little bit about IV&V performance, and then so SLS is a development very much falls under environment. So we will not be going too much into detail different elements. The picture here is basically a depiction of block 1, which is far left, block 1A, and eventually block 2. And basically, no differences on the top of the payload goes from 70 to 105, 130, advanced of different portions of it, primarily managing payloads and increasing question. Any questions here?
Something happened with your presentation, guys. Hang on just a second.
Right.
Where did it go?
There we go.
Okay,
thank you.
Sorry.
So let's chart here basically what we are looking at as far as the product. So we'll be providing an app critical SLS flight software. We're going to be able to this is a flight computer API software, which is primarily in green box on the left. Over here, GMC, FM manager, and support manager, and redundancy manager, and 50 degree. development, bringing in a lot of different elements. And this represents a lot of the IPPF uses the separation propulsion unit, upper stage, four stage, control units. The renewed navigation and the TVC stages and the real-time are part of it. And are ones underneath because of where they are and the resources we have available. All right. Questions here? Let's start with the next slide. This is chart stuff.
That's overview the enterprise architect. Or essentially, the SLS avionics team shows enterprise architect, which is produced by Spark Systems, as the unified modeling language platform to build the SLS flight computer avionics.
Here's the guy. A little bit of history of where we're at is primary development is in the Marshall Space Flight Center in Huntsville, Alabama, and the software development organization there has the responsibility of the flight software. EA is a product they are using, not necessarily the product that's being used by Renew or IPPS or the ECU. So I just want to, make a little picture for everybody. Right. So this is a light computer, avionic software we're running. Go ahead.
Okay. They're utilizing the UML platform to build the SLS flight computer avionics software up there. The architecture is going to be within that the software development lifecycle. After the tools including Credo, Rhapsody, and Core, or EA was chosen. EA is SLS flight software modeling integration advantages. With EA, create navigation using SLS vehicle function model. So in that sense, the flight software team, the avionics team, develop the IV actually pulls from that and we have our own configuration where we distributed database for teams to utilize, and we do our thing. The EA relies heavily on the hyperlinks between the diagrams, so it's a very nice tool for the complex software requirements, diagram structures, flows, and releases. Prior to we actually on a monthly basis pull off a build and perform our analysis. So the flight software team develops this platform, and the IV&V team currently takes that and utilize NDVO tools to perform functional analysis on the avionics requirements and design that are integrated into each of these builds. And we do this the SLS requirements and design are complete, correct, consistent, and unambiguous. So how essentially we have an interaction with the flight software team where they reintegrate the avionics into EA, and then we take that and perform the analysis. So we're basically in sync with the flight software team that performs the schedule of development, which they call sprint, which initially lasts 4 weeks. integrate requirements and design artifacts into the flight software artifacts into the EA platform. And it's, as Mark pointed out, it's for GMC, mission manager, board manager, communication, data handling, PNDH aspect.
Excuse me, a little more in the life cycle of like either software. We just had our PDR, and that focused primarily on getting requirements in order, and beginning development, design, and implementation. So software development organizations there have been using agile development principles and providing their process and this software development. The guy is he is looking for and seeing how everything to the EA model captured every report.
Okay. And the one of the notes is that when the software team develops and places these incremental builds into EA architecture, it's essentially to ensure every requirement run the design at that particular point in time. Next chart, please.
Yeah, and this provides us the ability to look at individual models as they're coming together, and we can do incremental trace analysis immediately.
Let's start this, and let's talk about how we use EA to meet our IV&V goals. So as these are into the EA platform, with like software requirements and the design artifacts that are integrated, such as the SLS black box requirements and the design level requirements or simply white box requirements. IV&V utilizes EA and their form immediate requirement analysis and review of the design and requirements across the entire SLS software for quality. Again, we're doing this entire software development cycle. EA requirement. So the first bullet shows the EA requirement tracing tool addresses the IV&V technical framework goals that we have here for our analysis 3.1 to 3.3. This particular EA includes parent-child tracing, viewing, and recording. And the flight software PDR is completed at the end of July, and the SLS IV&V team for the exam gentleman by Vimal Patel for the video who are down are leading the meeting. Next.
One guy talked about black box requirement. The development is primarily talking about their SRS.
The EA model addresses IV&V technical framework goals, essentially the 5.1.3. This tool FNEA linking design elements to the black box and DLR requirements, reviewing immediate impact analysis and reporting. EA model addresses the IV&V technical framework 3 to 5. This tool includes link issues of the design to the requirements for again reviewing, immediate viewing, and analysis. Find or any issue when we analyze the link. So I'd like to note that all the EA tools allow impact analysis on changes again throughout the software development lifecycle. Chart, please.
Let's not forget that along with these tools, we have our own scripts that help us do more, say, deeper level analysis.
Yes. So chart 6 essentially here is a cartoon, which is a repeat of the previous chart. So EA allows impact and actual comic-like software changes throughout the software development lifecycle. We can see the possibility when we have EA up and running. We have the vSAN, and we're analyzing. We can form stability out of the requirements. Parent style, we can look at the design in many ways for analysis. EA replacing tool addresses IV again, IV, the technical framework goal to 1.3.3. And if you look at the upper part of the cartoon, you see that the tool hierarchy, parent-child tracing, viewing, and reporting.
The 3.1 primarily traceability, the 5 traceability. Okay.
And the EA model addresses, yes, 5.3, and these are design issues. The tool, the design element, the black box, and DLR requirements for viewing and reporting. And then chart also being model mapping and addresses the IV technical framework goals, CS3 and CS5.
Yeah, the organization is primarily using the EA model to capture all design level requirements, and then they'll be using the generation tool out of the architects to generate design documents.
Next chart, please. This chart here is a continuation. This is essentially how IV&V utilizes EA. And this chart is basically highlights the reporting capability of the requirements when you're within the EA model to view various that we analyze. And EA is one of the points here at EA the advanced ML-driven architecture allows automatic interaction. Not only can you can view links, traces to the requirements for each one of the elements in the design, you can instantly view the diagrams to perform your analysis. Not only can you do that, it's very easy just to write this information out to support your analysis sheet or our analysis sheet. Next chart, please.
Yeah, I think when guys talking about analysis sheets, the analysis sheets we use as a template to provide consistent analysis, captured information and traceability. So it's important that we use the tools that EA provides us to get to that. Anything else to add to that, guy?
No, that's it, Mark.
Okay. So I think I have this table here, or this chart here. This chart here basically tells us, you know, what we're going to do from an IV&V perspective. You know, to do an IV&V using this tool, we're going to be, you know, focusing on these standards defined by the 9-01. And what Guy talks about as far as the specific tools will help us get there. Now, again, we'll be talking about 3 questions that you know we use to examine the behavior of the product under review, which is, you know, will the software do what it's supposed to do? will the software not do what it's not supposed to do? And will the software respond as expected under adverse conditions? So we'll be using these tools to examine all these things along with our rest of our IV&V technical framework elements and analysis checklist. And the next chart. Next chart here tries to outline what the tools capabilities are to our technical frameworks. And for instance, end-to-end traceability, we'll be using the requirements. We'll be using that tool to help us do requirements tracing and design level tracing. And these are the DLRs that Guy was mentioning, the design level requirements. Going up to the parent requirements and, of course, down to the design requirements and then down to the implementation. EA is a powerful tool that captures everything in one spot, and we will be able to show traceability through tables and traceability through graphical images. Anything to add to that, Guy?
No, that's about it. I could, we have a few minutes left, but the tools are very, as Mark pointed out, the tools are very powerful. The design level requirement link report as well as the issue report will instantly show disconnects with the requirements and the tracing, which is beneficial, very good.
Okay. Right. And we'll be using these tools against these TF requirements that are identified here, but again, we'll be using all our other IV&V functionality for the other TF goals also. So we just want to summarize here that, we do provide analysis of safety critical software. We'll be using these EA modeling functionality to support our objectives. And we'll be using those tools on the specific artifacts that we'll be looking at. We can use these tools to behavior in a very conditions, adverse conditions, nominal, and and using these tools to get all three questions for IV&V. As far as getting design and implementation and traceability down requirements. And we'll be applying these methods.
No, that's it. Thank you very much.
Any questions? Yeah.
Are there any questions in the room? No questions in the room. Any questions online?
And I'm here if anyone wants to come by and ask if it's go over details.
Okay, I'll give you any questions on the phone. If you have a question on the telephone, please press *1 to get the operator's attention. All right, and there are no questions. So we'll send you guys over to the breakout room just in case somebody thinks of something.